Okay, question number 15. Point A has coordinates -4 and 1, and the vector of BA -5 and -12. Find the coordinates of point B. Okay, calculate this one. Here we have coordinate of A is -4 and 1. Vector BA is equal to -5 and -12. So part A, find the coordinates of point B. How we can find? Here we can write A minus B equal to the BA, vector of BA. Then A gives for us -4 and 1 minus B. B is not clear. Instead of vector A we have -5 -12. Then we here can write -4 and A is the same. 1 is the same. We carry over this one, -5 and -12 equal to B. B we carry over to the right side, change positive. Then we have -4 and 1 here. We may calculate directly here. Here we subtract directly -4 minus multiplied by minus plus 5 and 1 minus multiplied by minus plus 12 equal to B. So the coordinate of B is equal to 5 minus 4 minus 1, actually plus 1, and 13. 12 plus 1, 13. This is the coordinate of B. Part A is solved. Now we come to part B. Part B asks us, point C has the coordinate point C. Part B, point C has coordinate 5 and -2. Find the vector CA. Find the vector CA. C is actually A minus C. So we have here for coordinate of A we has -1, -4 and 1. This is here minus C. C given the question 5 and -2. Then vector CA is equal to -4 -5, -4 -5 and 1 minus multiplied by minus plus 2. So vector of CA is equal to -9 and 3. So this is the vector of CA, -9 and 3. Question part B. We come to question part C. Part C asks us that you should find the EF, vector of EF. Vector of EF should find that equal to 3 times of BA. First we find the vector of EF, 3. BA has given the question here. B is equal to this one, -5 and -12. We multiply this one. 3 multiplied by 5 -15. 3 times of 12, 36. And also you should find here, ask us this, that find the magnitude or absolute value of EF. So the magnitude or absolute value of EF is equal to square root of 15 square plus 36 square. Here we can write EF is equal to square 15 square 225 plus 36 square. We multiply 36 by 36, 21, 3 by 6, 9, and also 2, 1. Then we add together 225. So EF is actually the square root of 1521. We can calculate this one, the square root. You are not permitted to use calculator for this one. So here we have 39, we subtract, multiply 3 and multiply by 2 here, 6 and 21. We work 9 multiplied by 981 and 9 multiplied by 6, 54. We have 62. So the answer is 0. The remainder. Then we can also find the absolute value or magnitude of EF is actually 39. This is the answer. The stream and leaf diagram shows the mass of each of 30 pockets. So here we have, according to this stream and leaf diagram, we can write here 31, 32, 38, 40, 41, 42, 43, 40, again 43 repeated, 48, 51, 52, 53 and 54. This is actually the information or data we take from the stream and leaf diagram. So what asks the question, work out the interquartile range. Here first we number different, for example we number, for example, this number 1, number 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. The number of data is here is 13. We first find median, actually Q2. Q2 is equal to the median 43. Then we actually find this the median, and we write here, because the number of data is 6, we find Q1. Q1 is actually the median of 38 and 40. 38 plus 40 divided by 2. 78 divided by 2, 39. Then we find Q3. Q3 is actually the median of these two. 51 plus 52 divided by 2. Here actually 103 by 103. divided by 2. Remain here 51.5. 51 by 5. Then we can find the enter I, Q, 3 and Q, 1. We can write here 51 by 5 minus 39. What's 0 here? Remain 5 and point 1 minus 11 minus 9, 2. We borrow from this one 4 minus 3, 1. This is the interquartile range, part A. This part A gram actually. 2 of these pockets are chosen at random, part B. Find the probability that the one pocket has a mass of more than 50 grams and other pockets has mass of less than 50 grams. So part B, how we can solve this one? Two of these pockets are chosen at randomly. 2 of these pockets are selected randomly. One pocket is smaller than 50 grams and the other is more than 50 grams. How we can select randomly? Then as you see in the graph here, okay, I first erase this part. Yes, here 15 actually between 50 grams is actually the border between 48 and 51. Here the border. These pockets are smaller than 50 and these pockets are larger or bigger than 50. The number of pockets are smaller than 50 grams is 9 pockets, and the number of pockets actually larger than 54 pockets. There we can have totally actually condition that we can write here. 9 multiplied by 4 is 36, and this is actually the favorable condition. Then we calculate the total condition. We here has totally 13 items and we choose randomly 2 items. So we calculate the combination of 13 factorial over 13 minus 2 factorials. This is the formula of combination. Then we can write 13 multiplied by 12 multiplied by 11 factorial over 13 minus 2 is 11 factorial over 2. Then we simplified and 1 2 6 times of 2 is 12. Then 6 multiplied by 3 18 and we have 6 multiplied by 1 6 48. Then we find the probability. The probability is actually P is equal to, here we have 36 over 28. We also can here simplify by 18 and this one is 3 6 19. 18 over 13 9 and also is 6 1 3. This is the probability that we will choose randomly 2 pockets from this actually data, or this is the probability that we calculate this one. Okay, now we start question number 17. This is very easy and a piece of cake. Should give your answer as a fraction in its simplest form. You should calculate this one. It's very easy. I like it very much. If you like, please like the video and subscribe my channel. So let's start it. Here we have 5 over 9 plus 0.28. Here we have 5 over 9 plus, we change to fraction, 28 over 100. Then we can take a common denominator as 9. Here we can simplify it. 7 times of 4 is 28 and 25. 5 times of 4 is 100. Then we take common denominator as 9 times of 25 divided by this 25. 25 multiplied by 5 plus divide this one common denominator by 25, remain 9. 9 multiplied by 7. So here remain 9 multiplied by 5 45. We have 4. 9 multiplied by 2 actually 20, 18 plus 4, 22. And also here we have 5 times of 25, 125 plus 5 times 9 times of 7, 36. Then we have here 225 over 3 plus 5, 8, 6 plus 2 also 8, and 1 is the same. This is the answer of number 17. Question number 18. We should calculate this one. Okay, how to simplify this one? The quadrilateral ACDE is formed by two right angle triangle ABE and BCD. AC is 17 centimeters, AE is 18 centimeters, and BD is 6 centimeters. Show that CD is 10 centimeter. Part A. First, we should calculate that CD. This one is actually 10 centimeters. We should prove. How we can prove this one? We write here. For example, this one we write here. This y. We use cosine of theta. Cosine of 60 degrees equal to y over 18. Then we use cross multiplication. Y is equal to 18 multiplied by cosine of 60 degrees. Here y is equal to 18 cosine of 60 degrees, 1 over 2. Yeah, we have 1 over 2. Then we multiply, and here simplify. 1 to 9 times of 2 is, so y is equal to 9 centimeters. So when y is 9 centimeters, then we subtract. If we call this one z is equal to 8 centimeter, because we subtract from 17. Then you know, according to the Pythagorean's theorem, x is actually the square root of 6 square plus z square. Z square, 8 square. So 8 is equal to 6 square is 36, and 8 square is 64. Then we can collect together or add together 100. The square root of 100 is 10. This proof. Part A. Part B should find the perimeter of the quadrilateral ACDE. And give your answer in the form of P plus Q multiplied by Q. Sorry, I have got flu. I'm not good, but I'm trying to solve this one completely. So here should we also find first ED. How we can find ED? First, to find ED, we use sine. We here write sine of 6 degrees equal to 6 plus DE over 18. Then here we have the sine of 60 degrees. Square root of 3 over 2 is equal to 6 plus DE over 18. We simplified this one. 1 times of 9 times of 2 is 18. Then we multiply to cross multiplication. 6 plus DE is equal to 9 square root of 3. Then we can write here DE is equal to 9 square root of 3 minus 6. We carry over this one. This is the amount of DE. Now we find the perimeter of the quadrilateral. So the perimeter of quadrilateral, actually the total length of its sides. We have here 17. Here we have 17 plus here we have x, actually calculate this one, 10 plus DE. Here DE we have 9 square root of 3 minus 6 plus actually AE 18 centimeters plus 18 centimeters. So it is the perimeter of this quadrilateral. We here 17 plus 10, 27 plus 9 square root of 3 plus subtract here 18 minus 6, 12. Then we write here P is equal to, we add this one number 7, 2 plus 7, 9, and 1 plus 2 is 3. 9 plus 9 multiplied by square root of 3. This answer is, the question asks us to should write your question as P plus Q multiplied by square root of q. This is the answer of this part. Question number 19. In the Venn diagram, sheet the region A union B union C complementary. Okay, how we should sheet this one? We should find the complementary. The complementary of this part is here. We can highlight with this part. Yeah, this part. Actually, this part is the we shade it here. I a little choose smaller. This part is highlighted. Actually, the complementary of A union B union C. So common part number 20. Question number 20 is very easy. A square root of here, right? Square root of 300 plus 48. We can write here 300, that 3 multiplied by 100 plus square root of 48. We can write 3 multiplied by 16. Then we can write the square root of 100 is 10, square root of 3 plus the square root of 16, 4. Then we add together this two smaller root. 10 plus 4 is 14, square root of 3. This is the answer. Question number 20. Part A and part B, you should rationalize the denominator and simplify. Here we write part B 9 over 2 plus square root of 3. To rationalize, we can write here 9 over 2 plus square root of 4. We multiply both of them with square root of 7 minus 2 over square root of 7 minus 2. Then we can write here 9 multiplied by square root of 7 minus 2. Here square root of 7 or square minus 2 square. Then we can write here 9 multiplied by square root of 7 minus 2 over, we directly simplified 7 minus 4. Then we can write here 9 multiplied by 7 minus 2 over 7 minus 4 is 3. Then we simplified 1, 3 and 3 times of 3's. So 3 square of root of 3, 7. Right here 7 and minus 3 times of 2, 6. This is the answer. Part B. Question 21. Write down the coordinate of the point. The graph of y equal to 5x minus 3 cross the y-axis. Here y is equal to 5x minus 3. Write down the coordinates of the point where the graph of y 5x minus 3 cross the y-axis. When x is 0 equal to 0, y cross the y-axis, or the graph actually cross the y-axis. So y is equal to 5 multiplied by 0 minus 3. So y is minus 3. This is the point. X is 0, y is minus 3. This point cross this graph to y-axis. Point B. A is the point. A is actually 1 and 7, and B is the point 5 and 15. The equation of perpendicular bisector of the line AB. Give your answer in the form of y equal to mx plus c. First we find the median of this point. Actually m is equal to 1 plus 5 over 2 and 7 plus 15 over 2. 5, 6 points divided by 2, 3. 7 plus 15, 22 divided by 2, 11. This is the median or average point of these 2 points. Then we find the gradient or slope of this actually m is equal to 15 minus 7 over 5 minus 1. We here had 8 over 4, then simplify, m is 2, because the question asked that you should find the line that is actually perpendicular. The relationship between 2m1 and m2 is minus 1. So if this m1 we write here, m2 is actually minus 1 over m2. Minus 1 over m2 is 2. This is m2. Then we use this formula here. Y minus y1 equal to m multiplied by x minus x1. Here y minus y1, this y1 is actually 11, equal to m, we have 1 over 2 multiplied by x minus x1. Here is x1 is 3. Then we simplify it here. Y is equal to minus 1 over 2x minus multiplied by minus plus 3 over 2, and we carry over the 11 plus 11. So y is equal to minus 1 over 2x plus 11 multiplied by 2, 22 plus 3, 25 over 2. This is actually exactly the equation of perpendicular bisector of the line A and B. This question 21 part B. And we calculate question number 22. Question number 22. A curve has the equation y equal to x cubed plus x squared minus x. Here we have an equation. Y is equal to x cubed plus x squared minus x. The curve has a stationary point. This is a stationary point, or actually a critical point, 1 over 3, and minus 5 over 27. Find the coordinates of the other stationary point. To find the other the coordinate of other stationary, we use derivative. We can here 3 squared plus 2x minus 1 equal to 0. Then we solve this equation. We calculate delta equal to b squared minus 4ac. Then b is 3 squared minus 4 is 3, and c is minus 1. So here is delta is equal to 2 squared 4 minus multiplied by minus plus 4 times of 3, 12 equal to 16. The square root of delta is the square root of 16 is 4. Then we write x1 and 2 minus, yes, here we have x1 and 2 equal to minus bb here minus 2 plus and minus 4 over 2a is 3. So x1 is actually minus 2 minus 4 over 6 minus 6 divided by 6 minus 1, and x2 is actually minus 2 plus 4 over 6, 2 over 6, 1 over 3. This one is given the question, and this one we should find. So the other stationary coordinate is actually we have point equal x is minus 1, and we should calculate the y. Y is equal to 1 cube minus 1 cube plus minus 1 square minus 1 here, minus the power of odd here minus 1, minus the power of even plus 1, plus minus plus multiplied by minus plus. This one is, and here is 1. This is the other stationary point of this curve, part A. And part B, by sketching the graph of y equal to x cubed plus x squared minus x, determine whether the stationary point is the maximum or minimum point. By sketching, when we sketch this one, actually the graph here, we can say it has 1 over 3. X is 1 over 3, for example. X here is 1 over 3 here. Y is minus over 5 over 20, for example. Here is minus 1 over 3 here. The other point is x minus 1, for example. Here is minus 1, and y is, for example, plus 1 here. It means when we draw the graph, maybe like this. So it shows that this point is actually the minimum, not maximum. By sketching, we understand that the this point is minimum. And part C, the equation of x cubed plus x squared plus minus x equal to k has fewer than 3 solution. Find the range of possible value for k. Okay, how we solve this one? Actually, use once again, it's repeated. I actually work this with red color because it's similar. First, you put here x squared, x cubed plus x squared minus x equal to k. We take derivative from both sides. It becomes 3x squared plus 2x minus 1 equal to 0. Then we find the root of this equation that we find here. X1 is actually minus 1, and x2 is minus, here we can say 1 over 3. 1 over. So when y equal to between this two, according to here, y1 is x minus 1, y1 is actually, here we calculate minus 5 over 20. No, the x1 is actually this others 1 here, yeah, 1, and y2 is actually minus 5 over 20. Between these two, y1 and y2, when k is actually smaller than 0, actually on that time here the equation has 3 solutions, because when you draw, for example, a line here in this part, I want to draw it very smaller than this. Yeah, this part has 3 solutions. In every actual intersection is a solution, but between the k, I write this one with this one, k include from minus infinite to here is actually minus 5 over 27. One solution, because in the intersection of the horizontal line with the graph is just 1 point, minus 20, 5 over 27. Union 1 to from this point here is 1, from 1 to plus infinite. In this interval, if the k take this actually equation has only 1 solution, other time has 3 solutions. 23 here, right? Simplify the square over 4 to the power of 3 over 2. We simplified here. First we write here a square, x over 2 to the square to the power of here, right? This the numerator we write here as a 3 and the denominator as degree 2. Then here we simplify 2 by 2. Actually the answer is x cubed over 2 to the power of 3 is 8. This is the answer, part A. And part B, find the value of x. Here we have 16 to the power of x multiplied by 1 over 2 to the power of x equal to 4 to the power of x plus 3. Here we can write here 2 to the power of 4 total of 4x. Here we reciprocal or inverse to the power of minus x. When you inverse a fraction, the sign of power or in this change or into negative. When positive, here we can write here 2 to the power of 2 total of x plus 3. Then we have here 4 times of x minus x equal to 2 to the power of 2x plus 2 multiplied by 3, 6. The bases are the same, so here 4x minus 1 is 3x equal to 2x plus 6. Then we subtract 3x minus 2x equal to 6, and here x equal to 6. This is the answer. It was the last of this part. Thank you for watching. It was really too long, and it was of course little tired. We have got tired. If you come to the end, thank you for watching. Please subscribe my channel, like my video, and write a beautiful comment. Unfortunately, in this video my voice was a little cracking because I was getting flu, and I will be better in the, I hope I will be better in the next video. See you soon in the next video. Thank you.